Captain Poobah, please read me practice problem number 4 from Module 6.
The Poobah accepts this gracious request. In the reaction from problem number 3, suppose the chemist wanted to make 100.0 liters of Freon, rights reserved, using excess antimony trifluoride. How many liters of carbon tetrachloride would the chemist need?
Okay, so give us the original. It was 3 carbon tetrachloride plus
was 2 antimony trifluoride.
How many? 1?
2. It was 2. No.
QSB.
FL4 yields 3.
No, FL3.
FL3. Right. Yeah, it's FL3.
Trifluoride.
Right.
You just said trifluoride. Okay.
Oh, there's no L, by the way.
No,
it's just an F. Yields 3CCl2F2 plus 2SbCl3.
Is that really the equation we have before? Well, I guess it is. Okay, so here we want to end up with 100 liters of Freon. This is the Freon. Okay, so we want to have how many? 100.0 liters. Okay, what kind of measurement is liters, Martin?
It's a volume.
It is. It's a volume measurement. Okay. Oh, one thing important that I forgot. Give me the phase information, please.
Okay.
Carbon tetrachloride is a gas.
First molecule is gas. Second molecule is solid. The third is also gas. And the last is solid.
Okay. So here we're going to employ what rule? We're going to employ Gay-Lussac's rule.
Yeah.
What does Gay-Lussac's rule tell us?
It's all connected. Ballistic stoichiometry.
So with Gay-Lussac's rule, as we discussed in the review questions, right? Gay-Lussac's rule tells us that the stoichiometric coefficients of the moles, right? For gases in a chemical equation relates to the volumes as well. That's so cool.
Yeah.
So we're not only using 3 moles of this and 3 moles of this, but we're going to use the same amount of liters.
3 liters, huh?
Because liters is volume. Okay? Where is Gay-Lussac's rule? Let's read it again. Let's just look at it to refresh our little brains. Gay-Lussac's law is on page 174. The stoichiometric coefficients in a chemical equation relate the volumes of gases in the equation as well as the number of moles of substances in the equations. So we can use this information to relate the volumes. So if we want to make 100.0 liters of Freon, how many liters of carbon tetrachloride? So these are both gases. This is the carbon tetrachloride. So the relationship is 3 to 3, or we can boil it down to 1 to 1. So if we want 100.0 liters of Freon, we need to use 100.0 liters of carbon tetrachloride. Okay? Does that make sense to you, my sweet?
Yes.
Wonderful. Okay, let's look at number 5. Please read it.
To make a phosphorus fertilizer, agricultural companies use the following reaction. You ready? Ready, kids? Ca3P2O8 plus...
What? Ca3P2O8.
Yeah. Plus 2H2SO4 plus 4H2O yields CaH4P2O8 plus 2CaH4SO6. The first chemical in the yield side is the
Product.
fertilizer.
Okay. So this is the fertilizer.
Mm-hmm.
So this is the purpose of the reaction, right? They're trying to make this phosphorus fertilizer. So
if 1.50 times 10 to the 4 grams of H2SO4 are reacted with excess Ca3P2O8 and H2O, how many grams of fertilizer can be made?
okay. Now, with Gay-Lussac's law, we can immediately relate the volumes of the gases. But we cannot do that with these kinds of things that are not gases, and these are not gases. So what do we have to do instead? We're not talking about volume. We're going to be talking about
weight, mass, grams.
first thing. So what did I write on the chalkboard yesterday? I said that moles are related to AMU, atomic weight, which is related to grams, right? They're all related to each other, okay?
Uh-huh.
So what you have to do is you have to take a substance and you have to figure out its atomic weight, and that tells you 1 mole has that many grams, okay?
Yep.
Can you please stop shaking my table, those people who are not part of this? Thank you so much. So let's figure out the atomic weight of this substance. Why? Because then we'll know how many moles of it we have. Then we can figure out how many moles of this we have, and then figure out how many grams that will be.
Okay, so
Okay?
H
So
is
first things first,
1.01.
H2SO4. We have 2 times 1.01. That's 2.02. What's S?
S is 32.1.
And
Oxygen is 16.0.
that gives us 64. So we add these up. What is how should I report this, Martin? I'm not going to report what I'm going to write here on the chalkboard. That's not going to be enough.
3, right?
It's not about numbers here. This is adding and subtracting. We're not multiplying.
So in that case, we are going to be...
No, it has to do with what? It doesn't have to do with how many numbers there are. It has to do with...
the decimal place.
How precise. It's called precision.
Yes.
Precision. So when we're adding and subtracting, we have to be aware of precision.
Yes.
But when we're multiplying and dividing,
we can go wild.
That's when we're working with sig, fig.
That's accuracy,
digits,
not precision.
It is not accuracy. It is precision. We're precise to the width place. These are precise to tenths. This is precise to hundredths.
So
how precise? No. We cannot be more precise than these are. Why? How could we be? We're limited by the precision. We can only be precise to tenths.
Okay.
So we have to round this properly, 98.1. So 98.1 grams of this equals 1 mole of H2SO4, okay? It's dihydrogen sulfate. So I don't have 98.1 grams. I have 1.50 times 10 to the 4th grams. What do I need to find out? How many moles is that? Okay, so I'm still working just with my H2SO4. I haven't moved on to my fertilizer yet. So I have 98.1 grams per mole, or 1 mole per 98.1 grams. What am I going to do with this information? I'm going to find out how many moles is this. No. 1.5. Come on. Have we been dividing with our conversion factors at all? No. We've been setting up a multiplication, and that's what we're going to do again. 1.5 times 10 to the 4th grams H2SO4 times. Now, what's the correct conversion factor? Here are my 2 numbers. I'm going to not write them out this time. I'm going to make you figure it out.
98.1.
No. What do we want? We want moles. So you're going to put moles in the
98
numerator.
Right.
Times 1 mole
over
H2SO4 per 98.1 grams of H2SO4.
Right.
Grams cancel. We're going to end up with moles. That's what we want. So now you can use your handy dandy calculator. And divide 1.5 times 10 to the fourth. Don't forget your 10 to the fourth. Might be easiest to just write it out. What's 1.5 times 10 to the fourth? 1, 5. Okay, 15,000. So 15,000 divided by 98.1 gives me 152.905199. So how many significant digits do I want? What am I limited by? This has 3. How many ones does this have? 2. So I can only have 2. So I'm going to say, so I have 152.905. That's too many though. So what are the 2 significant digits I'm going to use?
1 and 5.
1 and 5. So I'm going to say 1.5 times 10. So I wrote out my exponents. I just did 15,000 instead of 1.5 times 10 to the fourth. So I'm not really worried about my exponents. But now that I want to report it in scientific notation, I'm going to report it correctly as
1.5 times 10 liters.
10. That's not 1.5 times 10, is it?
Times 10 to the fourth. Second.
What is 152? Figure it out.
150. Oh, okay, right. So times 10 to the second.
Thank
yes,
you. 1.5 times 10. I know, but you were getting all. You also said to the 4, which doesn't make any sense. And that is moles of H2SO4. Are we done? No. Because now we have to figure out how many grams of this. We're not there yet, right? So now we can relate moles to moles. How many moles of H2SO4 to moles of CaH4P2O8? What's the relationship between those two? This and this.
That's 2 to 1.
It's 2 moles.
2 moles
of H2SO4
to 1 mole of CaH4P2O8.
Or 1 mole
of CaH4P2O8 per 2 moles of H2SO4.
H2SO4. Okay, so if we've got this many moles of this, and we want to find out how many moles of this we have, right? So now to get to grams, we have to go from moles to AMU to grams, right?
Mm-hmm.
So we're going to have to do all these steps backward to get to the fertilizer. All right, so which one are we going to use? We need to find out how many moles of CaH4P2O8 we're using. Which of these 2 conversion factors shall I use, please? Remember, I want to end up with moles of this.
Well, in that case, you use 1 mole of the...
That's right, the one that has that in the numerator.
Yeah.
So 1.5 times 10 to the second moles of H2SO4 times 1 mole of the fertilizer per 2 moles of the H2SO4. This thing out of our way, sorry people. Okay, so that basically means we're dividing this by 2. Okay, what do we get with that?
What divided by 2?
Look, we're just doing a simple division. 1/2 of this.
That's
It's going to be 0.75 times 10 to the 2, or 7.5 times 10 moles of CaH4P2O8. Okay, well that's good to know. 7.5 times 10 moles of that. How many grams are in a mole? Let's figure out the atomic weight of it. I'm going to erase over here this that I have. Is that okay?
Yeah.
Okay. This is what the number we're working with now.
Okay.
Okay. Oops. Let's do that. Okay. So I have CaH4P2O8. Let's figure out the atomic weight. What's calcium? What's its atomic weight?
Calcium is, okay. It's 40.1.
40.1 plus 4 hydrogen.
Which
4
is
times 1.01,
1.01.
so that's 4.04. You'll notice that almost never you're going to be able to use this 1/100th of an atomic mass unit because almost none of the others are listed to the 100th place. They're all in the 10th place. Whatever. Okay, next, 2 phosphorus.
Phosphorus. That's pH, right?
No, it's P.
Just P. Okay, well that's 31.0.
That's 62. And how about the oxygen? Oxygen is 16.
16.0.
Okay, so 8. 6 is 428. Okay, so now we add these up. We get 4, 1, 6, 14, 11, 13, 234.14. Is that what you get?
Yeah.
Did you actually add them?
Yeah.
Or are you just hoping that I'm right?
Nonsense.
Okay.
I never hope
So,
you're right.
There's 200, so we can't use this because none of these are precise enough. 234.1 AMU is the molecular weight of this unit. What is the relationship then between moles and grams? That means that 1 mole of this is 234.1 grams. Or 234.1 grams is 1 mole. To go from moles to grams, this is our final step here. Okay? We want to figure out how many grams of this. This is our question that we're trying to solve. We're almost there. So which of these 2 conversion factors are we going to use to convert moles to grams? On the left or the one on the right? This is our data, 7.5 times 10 moles.
With the grams on the numerator.
On the top, that's right. So we're going to say 7.5 times 10 moles of CaH4P2O8 times 234.1 grams per 1 mole of CaH4P2O8. Chunk, chunk, gives me grams. So what's that? Can I use my handy?
Yes.
There you go.
And multiply.
Multiply 234.1 times 75. Don't use the
234.1
times 75.
75 equals 17,557.5.
17,557.5?
Yep.
Grams. Okay. How can we report this? What are my limiting significant digits? Because this is clearly multiplication, so I have to use
show this
significant digits.
So 1.76.
How many? Can you answer my question?
3.
Yeah, we're given 3 here, right?
Right.
So that is, yeah, I wasn't using all my significant digits here. I screwed up. This should have been 1.50, right?
Yep.
Okay, and 7.50. So this is all good. 1.76 grams, or 1.76 times 10 to the what?
4.
10 to the 4th grams of CaH4P2O8. Yeah, I'm slightly off from the book, and the reason is because I left off one of my significant digits here. I should have had 3 significant digits, but this is good enough. We're not going to redo it. And we're going to stop here, though, and come back and do another video.